Hello everybody, Elias5891 is busy today teaching base conversions to some 10 graders. So filling in today it's Timwee with another KTANE module tutorial. If the text on the bottom of the screen isn't already enough of an indication, we're going to look at a module called SixTen. Let's begin by taking a quick look at what the module looks like. As you can see, the module has 3 rows of hexadecimal numbers. These are numbers that go from 0 to 9 and A to F, and each of them have 2 digits. We also see that they go in 3 colors, red, green, and blue. And we have 3 sliders at the top. Now, we don't yet know what to put in, but let me just quickly show you that you can use this slider to enter any number between 0 and 255, and the number is expected in decimal. Alright, so let's take a quick look at the manual now. Okay, so on the first page of the manual, it explains what's on the module, which I've already summarized. But the first thing that it tells you to do is to make some observations about the behavior of these numbers. You can see that they sort of flip up and down, left and right, and this tells you exactly what you need to look out for. So let's take a quick look back at the module, and let's observe how these rows actually sort of jump up and down, or rather when. So you will notice that the row sort of jumps down. So the green one, which is now at the bottom, will jump to the top, and everything will go down 1. Now, how often does that happen? Well, if you listen to the bomb timer, 1, 2, 3, 4. So it seems to happen every 4 seconds, but then also in between that, the numbers seem to change. Let's write down what we just discovered, that every 4 seconds, the rows cycle down. Okay, so the manual calls this the vertical cycle delay, which is measured in second. So the vertical cycle delay is 4. And then we have the vertical cycle direction, which is whether it moves up or down. And we've noticed that that is down. Now, unfortunately, delay and direction both start with D, so I'm just going to write out delay and write dir for direction. Now, then it also says that separately for each color channel, which is either red, green, or blue, we want the horizontal cycle delay and direction. So what does that mean? Let's take a quick look at the module again. Take a look only at the blue numbers now and try to ignore when they sort of move up and down. We now have a 0, 2 on the far left, and now the 0, 2 is here, and now it is here. So you can kind of see that the 0, 2 sort of marches leftward. So for the blue channel, we can say that the horizontal cycle direction is left. Now, how often does it do this? It seems to do that every 2 seconds. Do you see that? Right. Every 2 seconds. So the blue horizontal cycle delay is 2 seconds. Now we need to determine the same values for the green and the blue channel. Okay. So I'm writing down this information here. Alright, we also need the direction. And okay, so let's take a look at what the red horizontal cycle delay is. We can see that the dB has just moved to the right, and now it's moved to the right again, so clearly the direction is right. But how often does it do this? Well, it seems to be in sync with the vertical cycling, so we can just reuse what we've already found. The vertical cycle delay is 4, so that must also be 4, and it moves to the right. Okay, finally, let's take a look at the green channel. We have the number 8b on the left, and now 8b is in the second position, so clearly the cycle direction is to the right. But how often does it do this? Well, right now it was in sync with the vertical delay, but now it cycled just before the vertical delay. Right, so it seems that it's 3 seconds. Let's verify this. 1, 2, 3, bang. Okay, so it is in fact 3 seconds, and it's moving to the right. Okay, so much for the information on the module. We also need the actual hexadecimal digits. Now, obviously, since they cycle, you might ask yourself, well, where do I start reading? Well, we will notice later that this doesn't really matter. So I'm just going to write them down. However, it does matter that you have them in the right left to right order. So you just start reading somewhere and then just wrap around. So for the green channel, we have 4, 6, 7, 0, 8, Bravo, and Charlie 8. And then for the blue channel, we have these numbers. And these are all in hexadecimal. Okay, so now let's take a look at the manual and let's not get distracted by the flashing module. Alright, so apart from these shift delays and shift directions, what else does the manual want us to do? Each row displays a 32-bit value. Now that's interesting because we've got 4 hexadecimal digits. Each digit is of course 4 bits, so we do in fact have 32 bits, but we don't know where the 32-bit value starts. Right, the vertical cycle delay determines which 8-bit value in each row is the most significant. Okay, so the vertical cycle delay in seconds is always going to be 1, 2, 3, or 4. Right, if it is 1, then the most significant digit is the one with the lowest value. If it is 4, it is the highest value. Now in our case, the delay is 4, so we are in fact looking for the highest value. Now in hexadecimal, which of these has the highest value? Well, it is dB. So this one is the most significant. We need to keep the order of them intact, so we're going to put this in front. And this is now our 32-bit number that we want. Similarly, here in the green channel, the highest value is Charlie 8, so we're just going to put that in front. And here AB is the highest value, so this is already correct. Now, just as a point of example, so for example, if this one was the highest value, then we would be putting those two numbers in front. So you always want to maintain the sort of left to right order of them, but wrapping around. Okay, so now that we have that, what is the next step? For each color channel, cycle the binary digits in the same direction as the corresponding row's horizontal cycle direction, an amount of bits equal to the corresponding row's horizontal cycle delay. Now that sounded like sounded a bit dense, but let's figure out what to do. Well, it sounds like it is talking about binary digits. So surely we don't have any binary digits, so in order to obtain binary digits, we first need to convert these numbers from hexadecimal to binary. So I'm quickly going to do that. I'm just going to remove the spaces. I'm going to use a base converter website. I'm going to put that here and say convert from hexadecimal to binary. And hopefully I will get 32 digits. Now if you count these, you will find that they are in fact 32. And the same will happen here. If we take this and convert that to binary, we'll get 32 bits. But then you might find sometimes you will not get 32 bits. You might get only 31. Alright, I need to remove the spaces. Okay, so this is also 32 bits. And that is understandable because we were looking at the highest values. Now, hypothetically, if we had the lowest value as the most significant, and this was the number that we wanted to convert, then the conversion would actually give us fewer than 32 digits. This would only be 26 digits. In those cases, you would have to put zeros in front to pad it all to 32. Now, it makes sense that we would have to add 6 digits here, because the first digit is after all a 0, which translates to 4 binary zeros, and the 2 in binary translates to 0010. So with that out of the way, let's put this back where it was, because this is actually the number that we want to care about. The next step in the manual was cycle the binary digits in the same direction as the cycle direction. Well, that's either left or right. So here we want to cycle these digits to the right this many bits. So we want to take 4 bits and 1, 2, 3, 4. We just put those 4 bits at the front and everything cycles to the right. Now here we have a delay of 3, so we're just going to take 3 digits. And here we have a direction of left, so we want to cycle everything to the left, which means we put these 2 bits here because the delay was 2. Okay, so that was that step. Now let's take a look at what's next. Then cycle the color channels themselves in the direction of the vertical cycle direction. Now the vertical cycle direction was down, as you may recall. Right, let's actually, we don't need these numbers anymore, so let's get rid of these. I'm also going to get rid of the hexadecimal. So originally this was the red, this was the green, this was the blue, but now it's telling us to look at the cycle direction, which is down, and move all of these numbers down one channel. Okay, so obviously we wrap around, so that one goes up here. And now we move on to the next step. Divide the resulting numbers into groups of 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. So we have that. 1, 2, 3, 4, 5, 6, 7, 8. We have that. 1, 2, 3, 4, 5, 6, 7, 8. We have that. Okay, so we end up with 4 groups of 8 bits for each color channel. These represent the RGB values to be input in decimal using the sliders. Press the top screen to submit the color obtained from the first 8 bits, and so on. Okay, so it looks like we're going to need to convert all of these numbers to decimal. So let's quickly do that. We have this number here. This number here. We want to convert that from binary to decimal, and that gives us a 174. Now I'm going to do just the first numbers for now to show you how to enter this into the module. Okay, that's a 121. So our first answer is 174, 77, and 121. Let's move back to the module. So the first value, the red value, was 174. Now if you move past the value like I did here, you can use the single triangle to move the slider a bit slower, and you can press the screen to change the direction. Okay, so I pressed it in order to move left or down in value in order to reach 174. Now if I press the green one, you will notice that it goes really slow because we're still in slow mode. So let's go faster. We want 77 here. So that looks about right. And then we want 121, so let's go fast. That was a bit too far. And there we go, 121. And now, the pie chart, by the way, shows you the proportion of red, green, and blue values that you've entered, and there is a preview here of the color that you've just generated. Now, if we press the first screen, that color is now submitted. And now we have to do the same thing again with the remaining colors. So let me quickly switch back to the, there we go, to the notepad. So we can use our binary converter here to convert the next row of numbers. We get 108, 184, and this I can already tell is an 8. So there we go. All right, back to the module. The first value that we had was 108. So as you can see, the previous values are still there. So we can just manipulate these. So we want this down to 108. Let's do that. And the green value, we wanted 184. It's quite a lot more. Oh, that, I hit that by accident. And then we want 8, which is, there you go. 1, 2, 3, 4. Whoops, that was one too many. And that seems to have been correct. If the color that I enter is wrong, I will get a strike as soon as I press the... In fact, I can show you this now. There you go. You get a strike immediately, so it doesn't wait until you've entered all 4 to tell you which ones are wrong. Now that I have a strike, by the way, the timer on the bomb has sped up. It is now it now takes less than a second per tick, but the values on the module still shift in intervals of 1 second. So now relying on the bomb timer can be quite misleading. All right, let's go back to the values that we have and let's convert the next bunch. We have a 10 here, and then we have a 66, right? And then we have a 206. All right, back to the module. We have 10, 66, 206. So let's change this to a 10. 1, 2, 3, 4, 5 makes a 10, and then 66 here. We want that to go down. There you go. 1, 2, 3, 4, 5, 6. And finally, we have 206, which is quite a lot more than 8. All right, let's go back. 206. So let's go down. And then finally, we have only one color left to do. So let's convert those remaining values. That gives us a 42. This, I can already tell, is 253. Now, how did I know that? Well, all of the ones give you 255, and this is just 2 less than that. So that will give you 253. And then this one here is obviously 32 plus 1, so that's a 33. Nope, it is 16 plus 1, that's a 17. Good job if you noticed that when I said it. All right, let's go back to the module once again and enter those values. So for the red value, we want 42. Let's go a bit fast. That was too fast. Right, we want 42, so that's here. And then for the green, we want 253. 253. And then we have 17 for the blue. That was a bit too far, so let's add that. Now if I click this, I hope the module will be solved. Alright, thank you everyone for watching. I hope you enjoyed this tutorial video, and if you have any questions, comments, concerns or suggestions, please leave them in the comments below. And I will see you again next time with another KTANE module tutorial.